Good afternoon, ladies and gentlemen, and honored guests. I would like to introduce to you my fellow partners, I guess, from the far right. My far right, I guess, is Michaela Reitzma, and then beside is Sofia Captini. Beside myself is Ava Farkauser, and my name is Tizita Hill. We're all grade 10 students from Lacombe Composite High School. What do you remember when you were in high school? Perhaps crowded hallways, smelly gym lockers, and spending time enjoying time, I guess, with your friends. For a few of us, at Lacombe Composite High School, our high school education is being enriched by achieving goals, helping to responsibly manage our environmental resources. At the beginning of the school year, 4 of us, grade 10 students, joined Mr. Schultz EcoVision Club and chose to be the leaders of the New Leaves Project, which stands for Lacombe Educational Aquaponic Food System. The goal of the project is to symbolically grow fish, herbs for our school cafeteria in the most sustainable and watershed-friendly way. We believe that our plan to build an aquaponic system will encourage the community to grow their own food in a way that reduces the amount of water, nutrients, and chemicals needed, and therefore reducing the impact of our watershed. The watershed we are situated in is the Battle River watershed, although the water that we use is the Red Deer River. The Battle River watershed covers approximately 30,000 square kilometers according to the Environmental Alberta, and is located in central Alberta. Our project is important to us because we are passionate about the environment and we want to make a difference. We believe that through our project, we will be able to inspire the community to take part in caring for the watershed.
Watersheds fulfill 3 primary functions: to capture water, filter it, and store it in the soil in order to release it into a water body. Our watershed is not only important for survival of the people that live near it, but for the plant and animal ecosystems in that area. Earlier this year, a few of our group were privileged to attend the Navigate conference, where we expanded our knowledge about watersheds and how important they are to everyday life. Because knowledge can be such a powerful catalyst for change, it is imperative for everyone to be educated about their watershed in order to make a difference. The aquaponic system that we're planning to implement uses a massive amount of water, about 5,000 liters, and it can waste just as much if we aren't careful. Our water will be coming from the tap, which is water pumped from the Red Deer River. Our goal is to be able to reduce as much as possible, and the water that is necessary to use is planned to be filtered, cleaned, and recycled for recirculation throughout the system. In order to make our water use more efficient, we're going to create an aquaponic system that will filter the recycled water for practical use by living organisms. This will result in little wastewater, as 70% of the water will be recirculated through the aquaponic system, and the other 30% will be evaporated and transpired, therefore having a positive impact on our local watershed. For future projects, we would like to heat our water using solar thermal energy, which will cost approximately $10,000. We are following the ideas of Nick Savadoff, who at the Aquaponics conference hosted by NOAA Fisheries that we attended in Edmonton this year, instructed us in the most efficient and effective ways of a high school level of aquaponics.
Along with benefiting our watershed, the aquaponic system will affect all of Lacombe, including the Wolf Creek School Division. Lacombe Composite High School will be educated about the efficiency of the system. Also, we're able to inform the community about the importance of responsibly taking care of our watershed by managing our water usage. This system is unique because it can be implemented easily wherever there is access to water and a warm area, such as a greenhouse, a basement, or a classroom. With group efforts, our system can be implemented by nearly everyone. So the one-time initial capital cost to build our aquaponics system is $11,475. We have a quarter of it covered to date. The estimated cost of tilapia fish for a fully operational system per year is $1,320. The cost of seedlings for vegetables and herbs, about $360, and the electricity cost of $115. Last, the cost of water would be $3.60. Taking into account all of the annual expenses, the project costs add up to the total operation cost of $1,796 per year. We would like to see the aquaponics system up and fully operational by the end of May, but we are still lacking some resources. There are still several materials which will be required to ensure the efficiency and success of our aquaponics system. We already have our fish license, which is what Tizit is holding up right now. So, yeah. So, there are still a few materials that we require for our system. We still require a pump, plumbing materials, an oxygenator, a generator, a backup generator, food supplies, as well as what we have already listed.
The fish and herbs that we produce will be provided to our school cafeteria as an eco-friendly organic dish prepared by our food students. We are currently in the process of establishing a marketing scheme in order to provide our excess fish and herbs to local grocery stores, farmers markets, and local food bank. The Leaves Group was created with the purpose of managing and developing this project, as it is too big for just one person to handle. Our group of students have worked and will continue to work as a team to build and manage this aquaponics system. For the last 26 weeks, we've been meeting on a minimum 3 times a week for 45 minutes to work on this project. That is equivalent to 54 hours of work in kind contribution per person so far. We've been building it from scratch, gathering information from the Battle River Watershed Alliance website and the 2 conferences that we have attended. A lot of planning, work, time, and effort has been put into this project, and the success of it has become a personal mission for our group. In summary, our idea is to build an efficient and sustainable aquaponics system in our school's greenhouse. This system will benefit our watershed by raising awareness about environmental issues and promoting community involvement in caring about our watershed. Thank you for your time. Any questions?
Yeah, a couple of questions for you. Maybe it's a little technical, but what do you see that you need to do any pre-treatment of your water, seeing as it's treated water? Is there any effect that that water will have on your fish or your plants? And if you're not sure, even the treatment you spoke about as part of your system, you just touch on what exactly you're treating the water for. The filtration. The filtration.
The filtration is because there's 2 different types of bacteria that are going to be in our water, and one is harmful, and there is another type of bacteria that we're really trying to avoid, the E. coli bacteria, and that's a harmful bacteria that we do not want in our water, and that's going to be filtered out a lot by the plants in our aquaponic system, and the other bacteria are going to be kept in the water that the fish is going to be in, and through the biodigester that we're going to build.
And one other just question, have you considered a maintenance schedule or routine for your system? Is there anything that you might have to consider to keep it?
Absolutely. Because our system is very based on plumbing, all the valves are going to have a regular checkup and a regular maintenance schedule to be cleaned, but we're going to be using very organic, biologically friendly cleaners, anything like that, so we're not putting more pollution into the ecosystem than there already needs to be, or there already is.
Thank you. How many fish do you anticipate raising?
It depends. We started with a barrel, but it came as more educated we're getting. We discovered actually we're going to do a baroponics, which means we'll have 6 barrels so that we can have the different age groups. So I think we're starting with how many? Is it around? We're starting for our first batch will be about 200, and then from there it'll vary because of the different stages that they'll be in. So we'll be trying to stagger the different stages.
And how long will it take them to become mature?
It takes about around 6 months for one from the baby to fully grown. Yes.
Will your system run in the winter? Is it in a house? Is it in a honeycomb kind of building? Or how will you keep it running in the winter?
Yes, we are currently building our system in our greenhouse. So it's going to have a constant warm temperature throughout the whole year.
As you can probably guess, our greenhouse is actually one of the projects that our school did as well. And it has special features. Do you want to guess some of the special features for the greenhouse?
So, the judges, you all have your little pamphlets, and in it has like the dome shape, which is 70% more efficient. It has a polycarbonate reinforced R5 panels, which are really handy, and a large water tank, which heat and sink for the aquaponics, a climate battery, which is an underground cooling and heating system, solar power, because we have the solar panels on top of it, and underground insulation. We also have beeswax vents, so they open with the heat, and so if it gets too hot in there, then cool air from the outside can come in and cool it down more.
Yes.
Can you explain to us what a climate battery is?
Describe the fan system.
It's a fan system in a greenhouse just to adapt to the different weather changes and to keep the greenhouse at a consistent temperature using the water that is in the tank.
What supplies the heat? What's the heat source to maintain that?
Greenhouse isn't really our main focus. That was last year's project. Ours is the aquaponics project.
Well, what I'm getting at, I guess, is there's going to be costs involved in heating.
So we have a supplementary project. You want to talk about that? The solar tubes collecting heat? It's like solar panels.
One of our supplementary projects to this is after we've firmly established the aquaponics project and it's all running and going, we want to be able to use solar thermal energy through the solar panels and use that heat to heat the water for the fish. And we are applying for watershed money for that.
Any other questions?
Good work, guys.